Guideright 3mm depth stop Lindemann drills for mandibular anterior sites. This video outlines the application of Guideright 3mm depth stop drills, along with the protocol for creating surgical guides through a hybrid fabrication method that combines both digital and analog techniques. An impression of the patient is obtained and then cast in stone, or a model is generated if a scan has been conducted. A 3/32 inch drill attached to a lab handpiece is used to make 10mm deep holes in the cast. The holes are created at points where the implants are expected to be placed. The long axis of the 2/33 inch hole captures the long axis of the planned osteotomy. Two 3mm guide posts are placed in the proposed sites. The cast is lubricated with separating gel. 3mm guide sleeves are positioned on the 3mm guide posts for use with the diagnostic guide. Primotec products are used for fabricating Guideright surgical guides and can be purchased online from info@primotec.com. An initial application of Primo pattern LC gel red was applied to secure the guide sleeve cleats and cured for 10 seconds. Using your fingers, firmly position the splint material, ensuring no undercuts are obstructed to avoid the diagnostic guide from becoming trapped on the cast. This is a facial view of the diagnostic guide, which is placed in the patient's mouth and stabilized with a cotton roll placed between the guide and the teeth of the maxillary arch. A cone beam radiograph is taken to evaluate the position of the guide sleeve and the patient's mandibular bone. This is an anterior view of the diagnostic guide and the adjacent teeth evaluated in the cone beam image. The projected yellow line shows the long axis of the guide sleeve relative to the roots of the adjacent teeth. Note in the coronal view the alignment of the two axes of the two diagnostic guide sleeves. This is a cone beam image of site number 23 featuring the 3mm diagnostic guide sleeve in the diagnostic guide. To initiate the cone beam evaluation of site number 23, a blue line is drawn through the center of the 3mm diagnostic guide sleeve. To further evaluate this site, a virtual implant from the software is placed over the bone, and a green line indicating the long axis of the implant is drawn and is evaluated with the blue line, indicating the center of the guide sleeve. Here in number 23, note the angle indicated by the two yellow lines, which overlap the blue and green lines, is assessed with the apex of the angle located just below the guide sleeve, measuring 5 degrees, which is the correction needed to align the guide sleeve. Moving now to site number 26, again a blue line is drawn through the center of the guide sleeve. A green virtual implant is placed over the center of the bone, and a second blue line is drawn through the long axis of that implant. In this cone beam evaluation, the apex of the angle formed between the long axis of the guide sleeve and the long axis of the virtual implant is 17 degrees palatal. This location just below the guide sleeve is where the guidepost correction is made. To determine the offset correction of the guide sleeve, the distance of the faint blue line indicating the long axis of the implant is measured from the right leg of the angle. The distance measures 0.6 mm in the software, but it is rounded to 0.5 mm, equal to the smallest offset guidepost. Corrections are made using the Guideright bending tool protocol. Let's consider the angle corrections of both sites, which require two 0.5 mm offset guideposts. This slide illustrates the position 0.5 mm offset guidepost placed in the stylus, then into the bending tool block and positioned at the 0-degree mark. This two-piece 0.5 mm offset guidepost lower part is placed in the bending tool, and the stylus is gently pressed to the 5-degree mark to bend the post. The angle correction for site number 23 is illustrated, showing the 0.5 mm palatal offset guidepost before the bend is made and the same offset guidepost bent 5 degrees buccolingually. The offset was adjusted to prevent close proximity to the adjacent tooth number 22. In consideration of site number 26, here is an illustration showing the recommended 0.5 mm offset guidepost with the 17-degree bend. Note the advantages of the two-piece guidepost in this illustration. All diameter guide sleeves can be used by changing the coordinating diameter of the upper removable piece of the guidepost, which is available in sizes including 3, 3.9, 4.4, and 5 mm. They have a slightly smaller outside dimension than the guide sleeve inside dimension to fit the keys made for many of the implant manufacturers. The bottom half of the lower piece of the two-piece guidepost is designed with 8 flat sides allowing corrections in 8 directions. With offset and angular corrections made to the guideposts, we are now ready to begin the fabrication of the surgical guide. In review, 2 palatal 0.5 mm offset guideposts are selected to make the surgical guide. Each guidepost was corrected. For the number 23 site, the guidepost was bent 5 degrees to conform to the underlying alveolar crest. For the number 26 site, the guidepost was bent 17 degrees to adjust the buccolingual angle. Now to add the upper removable part. Two 2.9 mm upper removable parts are placed on the two-piece lower offset guideposts that were corrected 5 degrees and 17 degrees. 3 mm guide sleeves with cleats rotated toward the lingual surface have been placed over the upper removable parts. Light Cure Primotec red gel has been added to the guide sleeve to secure the cleats and then cured for 15 seconds. Primotec splint material has been added and cured to complete the final surgical guide. As illustrated here, the upper removable parts are removed from the cast before removing the surgical guide. The final surgical guide with the 3 mm guide sleeves is cleaned and disinfected with Paradex prior to surgery. We used the Guideright 3.0 mm Lindemann depth stop drilling protocol to place the implants in this case. The recommended application for the drills is in narrow surgical sites. Always start with the smallest drill length and then increase drill lengths to the final drill length for the osteotomy site. Drills must be used sequentially where they will bind. The 3 mm depth stop drills are designed to be used with 2.9 mm to 3.0 mm guide sleeves for guided surgery. They can be used as a starter drill without a guide sleeve. Increase the depth sequentially by 2 mm with each succeeding drill until the appropriate depth is reached. Drilling with the sequential drilling protocol does not result in significant heat production. The drills are intended for implants up to outside diameters of 3 mm or as a starter drill for larger implant diameters. Always use the manufacturer's drill for the final drill. For extra dense bone and deeper sites, pre-cooled drills, refrigerated external irrigation adds additional heat prevention. This is the surgical guide with Guideright 3 mm Lindemann depth stop drills in place 6 and 8 mm long are used to start the osteotomy. The drills must be used sequentially. That is, 2 mm intervals, starting with the 6 mm drill, continuing with 8, 10, 12, 14, 16, and finally 18 mm. The thread is very aggressive, so the drill will be easily drawn into the bone. One advantage to consider is that the thick cortical bone will not deflect the drills in the lingual area of the mandible. Caution: avoid using the drills above the mandibular nerve. A full-thickness flap is reflected to ensure that the guide sleeves align correctly with the underlying alveolar crest. The appropriate 3 mm depth stop drills are used up to a length of 14 mm for placing 12 mm x 2.9 mm Straumann implants. A Straumann 2.8 mm twist drill was used to finalize the diameter of a 14 mm osteotomy. The Straumann 2.9 mm profile drill was used to widen the neck of the osteotomy. The implants are placed 1 to 2 mm subcrestal. The labial plate has been perforated to open the cortical bone to facilitate cell migration for buccal augmentation. This is the cone beam taken to verify the implant placement and the thickness of the buccal bone. The cone beam scan indicates that the buccal surface of tooth number 26 has a thinner natural bone compared to tooth number 23. The grafting is made with 100 micrograms of BMP2 and 2 layers of osteogen strip, which is not visible because it comprises collagen and no mineral content. Grafting materials are placed after 15 minutes for the 90 micrograms of BMP2 to bind to the osteogen collagen. The final tissue closure was completed with PTFE sutures. Detailed product information, presentation slides, articles, manuals, and online orders are readily available at www.deplaque.com. For details, inquiries, and private consultation, contact Dr. Sean W. Meitner at swmeit4@gmail.com.